Hello again. So in this video, I'm gonna talk a little bit about the Python code used step by step for running a DBScan analysis. So as you can see, we start by importing the necessary libraries. These three libraries are kind of, even these four libraries, kind of every time we start a Python code, we probably have to import these libraries. And if you're into machine learning, then sklearn is the library to go to when it comes to the machine learning. So from the sklearn library, focus on the cluster module and we import the DBScan. So let's get started. And before that also we need to import metrics from the sklearn library as well, so that this is for the evaluation silhouette score. Let's get started. So I have this data set that I got from, let me show you the data set. It's called the customers clustering data set. And let's take a look at the data set. The customer clustering data set is an Excel, sorry, it's this data set is a very small data set. It's 200 data points, and it has a customer ID, it has a gender, age, annual income, and spending. Now, I said earlier in the previous video that DBScan uses Euclidean distance, and therefore it is the it's best used with this kind of data, continuous numeric data. However, it will run if we actually convert this categorical variable into numerical or binary variable, then it could be used, but in principle it is only used for a numeric data. So I'm going to start my investigation today using these three numerical data and data points. But however, for also customer ID, it is just a kind of partly considered mostly categorical data. All right, so now we are reading the data set. Oh, I didn't run. Okay, now we are reading the data set and using the read underscore Excel function from the pandas library. And as you can see, you can read this whole data and store it into a Python object called data. And if you want, you can actually create another Python object called df as a copy of the data. Of course, in my classes, in my physical classes, I used to tell my students, let's do df equals data and that's it. But it is best practice to actually use the dot copy, so that if there is any manipulation in the future code that we will do, the data itself will not be affected, and therefore the df will get the copy only from this stored data. So it's best to use the data.copy function. That is best really, because it keeps it for sure intact. Now I have given this code in my class to check for missing data points, and now we're making sure that there's no missing data points. Once this is all made or taken care of, what you need to do is to, I called it here xtrain, but actually maybe it's not the perfect name for it, because this is an unsupervised machine learning. So I probably shouldn't call it xtrain because of that, because in unsupervised machine learning, like clustering, we don't use any labels. But for now, let's just, overlook this little mistake, and let's, store these three numerical variables in a data frame and call it xtrain. Now we have also a DBScan function now. So first step is that we just, creating the data set. I'm not going to call it a training data set. So we create the data set, and this data set should be appropriate and appropriate for the nature of the clustering technique. So it's a continuous numeric for the default Euclidean distance used for density clustering. Then second is use the function. As you can see here, we are going to use the DBScan function. So the parameter it takes is the two main parameters that I explained in the previous video, the epsilon and the minimum samples. I will tell you how did I come up or was able to calibrate these parameters into 4 and 12.5. Probably the 4 is easy to explain right now because, as I said earlier, for minimum samples you need 3 dimensions plus 1. So we have 3 different dimensions, as you can see here, and then plus 1, that would be 4. So probably this is not very difficult to figure out. However, if you take a look at the epsilon, this is not a big challenge, but it requires a little bit of attention, and I will talk about it in a bit. So over here we are also not only using the function, but also 2-in-1. Using the function to identify its 2 key parameters and also fitting it on this data. All right. Now, as an output of this function, I would like to show you something, in fact, before I go ahead with the code. What does clustering gives me? Nothing, you see. Gives me clustering itself. It is the function fitted on this data. It gives me so far just the 2 key parameters. This is what it returns. But one of its products, its output, is actually the labels. So here, this is clustering dot the label. So if this is clustering 2 or clustering 3, then this should be clustering 3 dot labels. You got my point? So here, these are the labels, the resulting labels. And if you take a look at, for example, clustering itself is not a data frame. You got that, right? Now, clustering dot labels is an array. Now, if you take a copy of the xtrain, what is xtrain again? Xtrain is this data. So let's take a look. What is xtrain again? Here is xtrain. It's just the data. However, it's not the data set with the ID and other categorical variable like male and female. It's just the numerical data that we fed into the function and fitted it, the DBScan function, and fitted it onto the function. So now these are the labels. So what do you think I'm trying to do? I'm trying to create a data set that I can append or concatenate these labels into it. So I can see this, and which, cluster it actually belongs to. So DBScan dataset is nothing but a copy of that xtrain. So this is the DBScan dataset. Do you want to see it? Here it is, yeah. So this is the DBScan dataset. Basically, it's exactly the same as the xtrain, but now I want to add to it the cluster. So as you can see, DBScan dataset dot add to it the cluster, give me the clustering labels there. So this is kind of easy to just identify here or add a column and give it a name, whatever name that you like. This is why I added the dot loc and location, and I didn't just put, but I think you can still manage doing it the old way that we do it in class, but this is also a very interesting way of doing it. So you put it in this cluster and you put the clustering labels. So now let's run this, and I don't want to actually show you the clusters. It's going to be the same as this, but I want to show you the data set now. So it has become from age, annual income, spending, score. It now added the clustering. Remember again, if you are using different, if you are like funneling with these epsilon parameter, and you have clustering 3, clustering 10, clustering 20, so you're changing the name for the different parameters that you're using, then make sure that over here for the labels, you are actually using the same name so that you get the labels that are associated with fitting the data into that function with the different parameters. I hope now you understand this very well. So this is the first step, is how to run the function called DBScan function. The DBScan function takes two main parameters and you fit the data on it. This data, the X-train, is nothing but a copy of the data, not a copy actually, the X-train is all the continuous variables, because the DBScan only takes continuous variables in principle, and then you can add just the clustering labels into this data set as I've done earlier here. All right, so now the next step is I would like to know what are the clusters. So the labels of the clusters. So we have cluster label 0, 2, 3, -1, 1, 4. This doesn't matter. So we can say this is the first cluster, second, third, fourth, fifth, and sixth. In fact, if I want to put these clusters together, I would say that first I have a problem here. First problem is this cluster is over 50% of the data. So that is not very good practice, but it just, seems like these parameters, I will show you how I got to these parameters, or how do you get to the best parameters. That's the challenge, is the calibration of the parameters. I don't like the fact that one of the clusters have almost over 50% of the data, and then these clusters are very, very little, that I in fact could actually get rid of them as well. There are only like 8 and 4. And now the most important part is that we use this clustering technique not for clustering today. I'm going to talk about it. I'll talk about all this later, yeah? But today I'm talking about how to use a clustering for getting rid of outliers. So which one of these clusters is actually the outliers cluster? Always the cluster labeled -1 is in fact marks or flags the outliers, the cluster. So -1 cluster has 18 outliers. If you want to find out how many of these outliers are or the percentage, as I told you here, over 50%, and here is about 9%. It is not a very small number. It's 18 is like 9% of the data set is gone for outlier cleaning with this method. I'm not sure if you would like to tolerate getting rid of 9% of a data set that has only 200 data points. At this point, I might not use this method for outlier cleaning, and I'm probably going to use, or at least explore, other methods like the z-score or the IQR method, so that I can probably identify outliers better. Let's see. Now let's take a look at how to plot. Now, before I get into the code, which is not very, what I want to question is, what do you plot? Usually in plotting, you have to have an x-axis and a y-axis. As you can see here, I like to pull out the customer ID. Customer ID is a categorical variable, but it's not really like, it's very unique because it is, every record has a unique value, so it varies really with each record. So it's like a continuous variable in this sense because it varies a lot. But at the same time, we don't usually use any aggregation on it, like averaging or a median or whatever. So this is just for counting. So this is why I always advise my students, why don't you plot any variable against its customer ID? It's the best way, because this means nothing but the order of customers, the frequencies of the customer. There's no correlation really between the annual income and a variable called customer ID. So this way we can see that there is this linear line going up for the annual income. Seems like green is taking over the up to half of the data set, and then there is the purple. A little bit the top values are in this pink. This value is maybe misidentified because it is kind of like should have been pink. So now we know that these pink guys in the spending score, do you see that, love? Here's in the spending score that these pink guys in the spending score versus the customer ID as well. It does make sense that this is the annual income. There are people with annual income that has high annual income with the spending score could be, you see, this is relatively, the blue one is a high annual income, and the pink is also a high annual income. Do you see that? But not everyone with high annual income spends, their spending score is the same, like their purchases or spendings are the same. So over here, if this is the spending score, some of these pink ones actually have a very low relatively low spending score because they are nearby the zero, and these guys have a high income and a high spending. Do you see that? Now, with the green guys, you see that some of them are in the middle, and here they are in the middle. However, you see in the middle, low, high, low spending, middle spending, high spending. So some of the annual income is low, they still high spenders. These guys are probably their income is a little bit higher, you see, in between here and moving on to here. So they are spending a little bit higher. These probably guys a little bit on the low spending, and then you have the low spending customers. So that is quite interesting, isn't it? Isn't it? It does make sense to have some of these guys actually in k-means clustering. If you use k-means will take probably all these guys one cluster, all these guys one cluster, all this one cluster, probably, if you put it into 3 clusters. But over here we can see high spending score, high income, relatively high income, relatively lower income, high income, however, relatively lower spending score, and these guys probably low income, low spending scores, and then so-so income, middle income, and low spending score. It does make sense, doesn't it? It does. Now let's take a look at these, so I'm training you into how to understand these, do they make sense, As a marketer, you need to make sense of the data. This is what really matters. So over here you can see these black dotted points, and these are the outliers. Is this really an outlier? Look at it, how close it is. So I can, by eye, identify a little bit. So over here, if you count them, these may be outliers, ne? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So probably there's 13. 13 over 200 is around 7%. And these are not necessarily outliers. Do you see that? So this is not a very good method to identify outliers in very small data sets. Now, when we pulled out the customer ID, pulled it out from the DF or the data, or not the XTrain, because the XTrain doesn't have the ID. Do you remember? When we took the XTrain, we didn't put any of the ID. Here's the XTrain, doesn't have the ID. The only 2 data sets that has the ID is the DF and the data. So if you use the DF or the data sets, they have the customer ID, and you can add here, what you need to make sure is you have the data set that has the cluster labels. Which one is that? Which one is that? It's the one that we actually added the cluster labels to it. Do you see? So whatever name you give to this data set or the data frame, This is the data frame that you're gonna start here the code with, right? And then mostly you would need to change only the variables here. These variables, if they come from this DBScan dataset, you keep it as is, you don't need to put the DBScan, but if one of the variables you want to pull out from a different dataset or different data frame, that's possible. You just need to identify here and put it as a variable without the need for the label, all right? And also here, cluster should be the same name that you used here in the data frame. And here I just changed this and I added the DF customer ID to this one. Now over here, I am showing you another thing. Here, annual income and spending score. In fact, this is interesting. I want to start with this. So this is the annual income and the spending score. This is the annual income alone with the customer ID, with the customer ID spending score. Now, both of them together. So both of them together, it's very consistent. Do you see this color and this green, and here's the orange? Oh, wow, this is amazing. So basically here, which one of these variables, either this or this, is very important in clustering the spending score. So you can have a low, you can have a high income, but you will be classified into either high spending or low spending. Do you see how do we make sense of things? So spending score is said to be a very crucial dimension into clustering. This guy going up right there, not much of like densities, but this here is showing us patterns, and these patterns also are very consistent with annual income and spending score. So do you see that? Same almost everything. It's just that this is a spending score and this is annual income. Annual income is high. If you want, I can change the position. Maybe it's better. Let me change the position. Let me do that. Maybe better. So this is spending score and this is annual income. So this is annual income. Here, this is high annual income, but some of them spends more money, some of them spends less money, and so on. This is what I was talking about earlier. Now, these guys are not outliers. 1, 2, 3, 4, 5, you know. These a little bit could have been by eye considered not outliers. Anyway, when there's not much density here, as you can see, it's better to use any other method. Now let's talk about the age, the categorical variable. If you want, you can put the age here as a categorical variable with the customer ID, but in fact the age would be really meaningful to use with the spending score rather than the customer ID really. So let me take the spending score from here to make it a little bit more meaningful, and let me plotted with the age. So seems like this data set is very consistent. So most of the customer ages, so even when we have it with the customer, with the age and the customer ID, seems like most of the customers are within 40 and 60, actually 20, minimum 20, you see? You see that? 20 and up to 60. Let me just, for fun, let me just try to find how does age goes with annual income. So let me put annual income here. And how about I take age again now? I'm sorry, maybe it wasn't a bad idea to put age and the ID together. I love always to see the ID and how the age and the ID, any variable with the ID, will give me a very good look at its behavior and concentrations. So let me just put here the ID, annual income, spending score, we got it, so here. Let's run that. So here I have the it's better this way. So here is the age with the customer ID. A little bit 20 years up to 70, in fact. Okay. Okay, you have 200 data points. And then over here with the annual income, seems like this is okay, annual income, but some of the young people has a very high annual income. So what are the orange guys? But here's the annual income is low. Did I say high? This is annual income low. So low here, but and low spending. So spending score here with the annual income is that low annual income and low spending, but they don't seem to be here. Still lower annual income, but a little bit high in, yeah, so these guys are supposed to be at the age of 40 to 60. Most of the population here, do you see the green and pink? Most of the population after 40 is green and pink. What is green and pink? Green, as you can see, the spending is either, and here is pink. So their annual income is high, or annual income, where is the annual income here? Is either pink or purple. We should think of it this way. So the spending score and the age, and this is the annual income and the age. So annual income seems to be a little bit, not very much affected by the age as well. So you can see also here the age has a very dispersed distribution. Okay, so I don't think if we add the gender, the age. This is the age and not the gender. Did we do the this is the age? Okay. Yeah, that's the age 40 and 60. So we could probably also just plot it against the category male and female and find out if you are curious. But over here in total, in general, in summary, you can see that most of the people below 40 years old are in green, a little bit in purple, means they are either their annual income is low, medium, and a little bit high. The population will be here in purple. And then above 40 also you have a low income above 40, annual income above 40. Some of them are given the orange, because most of the people above 40 are either medium or high income. But this is annual income. Okay, where is annual income and ID? This is annual income and ID. Okay, I see that. You see? And they are low spenders. This is why it's in pink, because they are relatively low spenders. Even though their income is very high, they are low spenders. But in purple, this means that they are high spenders. Even these are guys, seems to be people who are younger with higher annual income. Younger? Did I say that correctly? People who are younger. Yes, indeed, because the age here People who are younger are purple. People who are younger and purple, they have high spending. Do you see how do you make sense of the results? People who are younger, younger means younger, below 40, a little bit below 40, relatively younger, below 40, with high, with relatively high income, as you can see, they also high spenders. You see, annual income is high, their spending is high, they are young. Annual income is high, spending score is low, they are a little bit older, a little bit, most of them are above 40. Do you see that? Do you see? And this is how we make sense of results. For the evaluation, we ran the silhouette score for these parameters. Which parameters? Remind me again, the parameters of the DBScan function. The parameters of this DBScan function, which is the epsilon was 12.5 and the minimum samples were 4, the resulting evaluation metric, the silhouette score, was not very good. It was, however, it was positive. That's a good thing. It wasn't too close to 0, but it's close actually. Anything like it's on that in the first 25%, the first quarter. So a little bit close to 0. Anything maybe beyond the first quarter, beyond the 25%, could be considered reasonable or medium distance away from the 0. So, but this is the performance at these parameters. Now, how do we act on results? So these are the outliers. They are extracted from the DBScan dataset. Which dataset is this again? This is the dataset that has the cluster that we concatenated the cluster labels in it. So this is the dataset. Whatever name you give it, then you take this dataset and say, I would like to extract all the rows that has the following or satisfies the following condition. It's equal to -1, the cluster label. So you could also put here, instead of this, you know what you can put? I think instead of this, I could put something like, I could put something like, be careful here. It will give you an error, do you see? So you need to put here and put cluster dot. So another thing I would like to talk about, we can put clustering dot labels. Let me check, can we do that? Let me go up here again. And can I put these instead? Let's see. Let's see, can I, instead of this, yeah, can I instead replace it with these labels? Oh, this will take forever, so just, and it's giving me a little bit of an error. So you can't just put clustering labels in there. So please don't do that. Why? Because of a problem in the, this is gonna be an array, seems to be. So it gives an error. So don't do this. And instead just use my method where I'm using this data set where you put the cluster in it, and you always, the -1 is the label of the outliers. And these are the records that you potentially could delete from the dataset. And you want to delete these records. So because of that, you need the index, the rows numbers. So you need this one. So you can extract this by outliers.index. So this is what you're getting. You're getting the index of each row. And then you use the data drop. Why data? You can use data. But if you want, let's take a look. What is the DF now? DF is actually everything, customer ID. What is data? I told you that the DF is a copy. The data is also, they are a copy of each other. So you could either choose which one you want. I'd rather to keep multiple, you know, copies for a reason. So because of calibration purposes, yeah. So you can use data.drop and then copy this output here. So you can use either data or data frame, all right? So you can either one of them. Once you decide which one you want to use for this calibration method, you can copy these and then feed it into the drop. And don't forget to add in place. You don't have to put the axes because the axes is always the default is the row. We used to put axes equal 1 because we want to change the default from 0 into columns, which is 1. And then once you do that, then take a look at the data shape. Here the data, the original data was 200 rows, but now after deleting these 18 records, it has become 182. So that's it. You can then save your clean data into an Excel sheet by using DF or data. Actually, DF is not clean data. I used here data to drop the variables. Oh, I also used DF. Okay, as you wish. I don't know why I did this again. There's no need for that, right? So now, if you want to drop, you can. I don't know why I repeated myself here. Maybe I was configuring. Anyway, you can put just here data to Excel, and I am repeating myself, so there's no need, ne? There's no need, okay? So that's it all. In the next video, I'm gonna talk about how to manipulate, not manipulate, but configure or calibrate. Why did I put manipulate, calibrate? Nothing I hate more than manipulative people. So calibrate the epsilon and the minimum samples for calibration, or let's calibrate these two for best results, in fact. So this is now looks better, and in the next video.